Identifying polar and nonpolar covalent bonds with symbols. So below, they're asking us to select the polar bonds below. So here we have five bonds that are going on, and we have to figure out which ones are polar. Remember that polar means that the electrons are being shared unequally. So there's going to be something called a dipole moment. And what a dipole moment means, di means two poles. And we know what those two poles are. They're going to be a positive pole and a negative pole, because one atom is going to be more electronegative and become more partially negative, and the other ones will lose that electron for a while, so they're going to become positive. And they're going to call this a dipole moment because this doesn't happen. It doesn't stay constant. If it really stayed constant, it would not be polar, but most of the time dipole moments happen because the electron has decided to be in that vicinity of the more electronegative ion, of the more electronegative atom. So here we have A, B, C, D, and E. So O and H have very polar bond because of their electronegativities being further apart than closer. So A is going to have dipole moments, and that is a polar bond. Br and Br have the same electronegativity, so this would be considered a nonpolar covalent bond. So I'm going to cross that out. B and F, because of the distance they are in the periodic table from each other, you can see that there is a difference in electronegativity, and so that must mean that this is also going to form a polar covalent bond. N and N, again, same thing as Br and Br, bromine and bromine, because nitrogen and nitrogen both have the same electronegativities. Notice that this is going on between nonmetals, so we're talking about just covalent bonds here. P and O also have further apart electronegativities, so E is also an answer because they do have dipole moments where electrons are being shared unequal. Their valence electrons are being shared unequally. So we have three answers to this problem: A, C, and E.